This week is another free body diagram challenge. I'm Scott from RedmondPhysicsTutoring.com, and this video will challenge you to draw a pair of free body diagrams for a rather unusual situation. A truck delivering a crate of golden skunk statues, that's the strange part, is sliding down an icy mountain road and is about to crash. Luckily, Superman is there to save the day, which is not strange at all. There's no friction between the truck and the road, and don't try this at home, the crate of priceless statues is not attached to the truck. It's only held in place by friction. In case you're concerned, I can tell you that this story has a happy ending. Superman does slow down and stop the truck and the crate. Also, no skunk statues were harmed in the making of this video. Given all that, we need to draw two FBDs, one of the crate of skunk statues and one of the truck. To get the most out of this video, please pause here and try to draw the FBDs yourself. Don't worry, I'm not grading you, just do your best, and when you're done, hit play to check out the solutions. Ready? Let's go. I'll start with the crate. Superman is slowing it down, which tells me that the acceleration is in the opposite direction to the crate's velocity. Therefore, acceleration is up the mountain road, and I'll draw it with a squiggly line off to the side. Now, what forces act on the crate? There is weight, FGCE, which is the force of gravity exerted on the crate by the Earth. There is also a normal force, FNCT, acting on the crate by the truck. And this normal force is perpendicular to the contact surface and upwards to prevent the crate from passing through the truck. Finally, there is friction, FFCT, which is the friction on the crate by the truck. The direction of friction is in the plane of contact, parallel to the bottom of the crate. The crate's weight actually tries to accelerate the crate down the hill, so in order for the crate to slow down, the friction force must be opposite the crate's velocity. If you don't know the direction of friction, it's often okay to guess and work through the solution. Then, if you get a negative value for friction, you just guessed incorrectly. This doesn't always work, and getting it right just comes with practice. I'll also point out that writing the force descriptions is optional, but I often recommend it because it reinforces Newton's idea that each force acts between two objects. It also confirms that you have the right forces, since each one is exerted on the crate, which is the object for this FBD. If you see a force exerted on something else, it does not belong on the crate's FBD. Before we're done, we need to add axes. Choosing plus x in the direction of acceleration makes the math easier in two ways. First, the net force along x is equal to positive mass times the acceleration along x. And second, only one force, FGCE, has off-axis components, so we're minimizing the math. Now I'll look at the truck. Superman is slowing down the truck too, so it is also accelerating up the road, opposite its velocity. The truck has weight vertically down with FGTE, the force of gravity exerted on the truck by the Earth. There's no friction between the truck and the road, but there is a normal force. FNTR is the normal force on the truck by the road. There's also FTS, the force exerted on the truck by Superman. Am I done? I still need axes, and I would choose an angle that matches the incline to again make the math easier. There's still something missing though. If the crate was empty, it would hardly exert any force on the truck, but if the crate was fully loaded, then Superman would have to do more work to prevent a certain catastrophe. The crate does influence the truck through Newton's third law. The crate exerts two forces on the truck. FFTC is a friction force exerted on the truck by the crate, and by Newton's third law, FFTC is equal to negative FFCT. These form an action-reaction pair between the crate and the truck. Similarly, FNTC is equal to negative FNCT, where FNTC is the normal force exerted on the truck by the crate. That's it. The FBDs are done. I'm Scott Redmond, and I help students pass physics. If you have any questions or other feedback, I would love to hear them in the YouTube comments. Good luck with your FBDs.